My goal is to give you some class time, at least 10-15 minutes to try some of these here. So combined uncertainty, that's the next big ticket item here. So we've explored how each measurement has an uncertainty or margin of error. This is due to the limitation of the measuring device, known as the precision. So precision affects your uncertainty, always. They're very much related. But what happens when you combine measurements, right? So what will happen when we combine measurements? So when we have when we're using a measuring tape and we keep adding to a pile, or we're weighing. I'm always the weighing part. I just went to South America. I flew to South America this last summer. And what do they do before they board a plane? All the luggage needs to go in, right? So they weigh everybody's luggage. You put it on the scale, and then whoever is on the desk, whatever, writes down the weight. And so they just keep putting it into the belt, and it just goes into the belly of the plane, right? So I'm thinking every time they measure, they weigh the luggage, it keeps being added on to the pile, right? So there's some kind of combined uncertainty. It keeps on piling up. So that's the idea here. What happens when we start thinking about that? So this is I'm going to use a different color because I want this to stick out. The total or combined uncertainty is the sum of all uncertainties present. So we basically add them all up. Okay, that's what happens when. I think I'm going to give you a quick example right here. So let's say you have a piece that measures 3 centimeters plus or minus 0.1 of a centimeter. And you have another piece that measures 2 centimeters, that's plus or minus 0.6 of a centimeter. So what happens then? So if I were to combine these pieces together, let's say you glue them together, or you sew them together, it could be fabric, it could be anything. Obviously, I think everybody would agree you would go 3 plus 2, that's 5. Right? And the same thing happens to the uncertainties. 0.1 and 0.6 gives you 0.7 centimeters, right? So I want you to use the same color if you're highlighting. I want you to highlight this. This is what we would call the combined uncertainty. Right? So you add it all up. So, and the idea stands, right? Like if you're off here and you add something else that is also off, then it just keeps getting, right, compounding the total uncertainties. This is due to the fact that each time something is measured and added to a total, the uncertainties also increase. The margin of error increases because something is measured repeatedly. Okay? This is the idea here. The margin of error, which is the uncertainty, increases because something is measured over and over again. It may seem insignificant in most sectors, but it is very important to consider it in some other industries. Okay? So I'm giving the example of the plane here, okay, or even a gas station. So a gas station, obviously there's this big tank underground somewhere, and every time somebody's pumping their car or filling up their car, something is drawn out of it. But the pump can be off every time, but just a little bit, right? Every time a car comes and pumps, it'll be like, 20 liters plus or minus a little bit. 30 liters plus or minus a little bit. So we don't always know exactly how much is left. It could be off, okay? So that's the same idea. All right, so let's put this to the test here. I feel like I want to, no, I'm going to do that later. I'll do it later. Let's do this example here. 3 pieces of fabric are all being sewn together. Determine the precision and uncertainty for each piece. This is basically what we've been doing all along. Okay? Let's do that first. So what I like to do is, when I have my pieces, let's say they just mention it in a text, I like to line them up like this, and then I figure out the precision of this. What's the precision of this? 0.1, correct? And the uncertainty is half of that. That's 0.05 of a centimeter. This is really what we're after. Then piece number 2, guess what? It has the same same precision, right? It's just 1 decimal place. Happens to have the same uncertainty. The third piece, I did this on purpose. It's not always going to be the same, by the way, so watch out. The precision for this is still 0.1, and obviously the uncertainty is the same for all of them. That's A. So A is taken care of. We got this. Check. We found the precision uncertainty for each piece. B, calculate the total length and the combined uncertainty. Okay, so again, emphasis on this part right here. Okay, this is what's different now compared to grades where you were younger, where you just add up the pieces that were sewn together. So I put a line under here, almost like doing a vertical addition here. So I will add all the pieces up, right? I add this, this, and this together using a calculator, of course, if you need to. 95.8 centimeters. I ignore the precision. I put plus or minus there. I ignore it, but I will just add up these ones here. And so you can do it in 2 different ways. You can either go 0.05, right, 3 times. Oops. And you get that, or you can go, if they're all the same, 0.05 times 3, you get the same answer. So let's say I would ask you to sew together 100 pieces that all measure 5.4. I don't want you to do this 100 times, hopefully. You know that I would expect you to just multiply this by 100, multiply the uncertainty times 100, you got it, okay? So, but when it's like this, it's more than likely that you probably better off doing this separately like this, and then add them all up. And so our combined uncertainty is now 0.15 centimeters. Okay. So we always add the uncertainties, always. Okay? So this one right here, just this part right here is the combined uncertainty. And I need to be clear here. If they only ask for the combined uncertainty, you have to circle this. That is what is the combined uncertainty. If they just ask you for the total measurement plus or minus the combined uncertainty, then this whole thing is it. Okay? So this is the total measurement. Okay, so there we go. We've got that. C, determine the longest and shortest possible combined length. Just like before, guys. Imagine you've just combined everything into just one. So now the maximum is this plus this, right? And then the minimum is this minus the combined uncertainty. So max is 95.8 plus 0.15. The shortest possible length of them all being sewn together is the total length minus. So you get 95.95, and don't forget your units on your final answers. And then 95.65 is the minimum combined. So this is the longest, shortest. Just like that. They've done fencing around the house. They've done scooping out water with a little cup from a big bucket. All kinds of stuff. Okay. So I kind of just tailored this booklet to that as well. So let's go to 26. So this is where we were adding both sides. So I could just added everything up. Let's go to 26 and see what happens when you subtract the actual amounts. What happens to the uncertainties? It may be, it's kind of counterintuitive. Let's go to 26. Last example, then I'll let you try it right away. Moses has a bucket of water with 20.5 liters in it. He needs to draw some water. Okay? You're drawing, you're taking away for some plants using a smaller jug, which can hold 1.2 liters. If Junior draws 3 jugs from the bucket, determine how much water will be left in the bucket, including the uncertainty. Okay. So in this case, because we're doing something over and over again, we're talking combined uncertainty. Okay. So I'm going to do this the long way. I know some of you will do it faster later on, okay? So bear with me. We've got our bucket. We're going to subtract a small container, another small container, another small container. We're taking away 3 small containers, right? Scooping out. Let's do this part right away. So 20 minus 1.2 times 3, basically. 16.4. That's how much is left in the bucket. But grade 12 came along and made this all so much more complicated, right? That's what it means with the including the uncertainty. So what we need to do is we need to find the precision for every single one. And I made sure, again, they were all the same. So what's the precision for all of them? They all have 1 decimal place, correct? So in this case, we can just copy paste. So therefore, the uncertainties are all going to be half of that. They're all going to be the same as well. Just read carefully. So I extend the line. Please never, the precision doesn't come into effect here. We needed it to find the uncertainty. So just put a plus or minus like that. It's almost, you know what, it didn't even ask for precision, so I'm just going to do this right now. We don't worry about it. Don't cross it off completely. You want to be able to see what happened there, right? And so now they're all the same, right? So I will just take, so all 4 of them need to be added. Listening to this part, you always add your uncertainties. No matter what happens to the left side here, you always add. Okay? So I will make a note, add, always. Okay? So I'm just going to go 0.05 times 4 because I like to save some time. And so this is the answer. This is answering A right here. How much is left, including its uncertainty? So when you get a sense of repetition, repeated, right? Obviously, we're in precision measurement. Everything has precision and uncertainty. We no longer just stick to that. Okay? We always have to consider the precision and the uncertainty. So that's A. B, what is the maximum or minimum amount of left in the bucket? The maximum that could be left there is 16.4 plus 0.2. The minimum is 16.4 minus 0.2. So this would be 16.6 liters or 16.2 liters. Did I make a mistake? 16.9, right? Hey, I know you're going to be mad at me, but it's an easy fix, okay? See? It's like nothing ever happened. So you go over here, and you make this a 9, and you make this a 9. So that makes this is going to be a bit messier. Sorry about this. This is 17.1. Was it on the calculator 16.9? I just wrote it down 16.4. Something went wrong. 16.9 minus 0.2, that's 16.7. This one is okay to fix here. You can definitely tell something happened, right? If you look at this. Anyways, we fix it. So my bad. So this is it. So C, if Junior needs 17.5 liters to water a tree, will he have enough? In other words, is there enough in the bucket? And no, there isn't. Like, even if you consider the maximum possible that could be there, the answer is no. So you just say no, since the most that can be left in the bucket is 17.1 liters. So in this case, obviously you'd be like, duh, I'm just going to use whatever is left and water the small tree. We say, no, we cannot do it. We're short. Okay? There you go. So you know what? The good thing is we're still practicing precision uncertainty. Is this the only thing you can expect? No. You have to be ready for various cases. Read carefully. Is the precision always going to be the same? No. It's not always going to be the same, which means all the uncertainty going to be different. But if you just follow and you're careful and then you just add, right, you will still be fine. Always add your uncertainties. That is the key. Subtracting here or adding here, that will depend on the scenario, right? What is happening? Is something being taken away? Is something being added, right? Combined, you will be the judge there. So I'm going to ask you to use the rest of today's class to go and work through these. You know what? I give you class time to work. Why wouldn't you take advantage of that? You get to ask questions, you get to prepare, and then there's less for you to do outside of class. What should you do on your study sheet for this? You should have a section called Combined Uncertainties, in my opinion, and have a small example there. Like, if I'm going to be honest, like if you could just have a combined uncertainty and then this statement and a little example like that, then you at least know, okay, I know what that means, right? That this is the combined uncertainty. So I would definitely have that because, by the time we get to the exam, this will be, we'll have done several units after this one, so you will forget how to do it, okay? So all of those things are things you can do, and I'll look for the key and post it.